So we're going to look at the 1.3 notes today, and to do that, we're actually going to do only part of this page. This page has a graph and a table, and we're going to look at the left column under each graph. The right column is part of our 1.4 notes, and that'll be in a separate video. So to fill in this table, I've pre-filled in some of the x values for you. So I want to take those x values and let's calculate what the y values would be that go with them, and then we'll plot these parent functions on these graphs here. So if you take -2 and plug that in for x for a function, if y equals x, then -2 would be the y. If you plug in -1 for x, then -1 would be the y value. If you plug in 0, you get 0, and then 1 and 2. And if we plot those points, 0, 0, 1, 1, 2, 2, -1, -1, -2, you should recognize this is the linear parent function. It is a line that goes through 0 and goes up 1 and over 1. The next one, let's talk about, is that a function? Well, if you remember, to be a function, for a relation to be a function, it has to pass the vertical line test, which means any vertical line hits it once, which means the x's don't repeat, because you can't change the rule and get different y values for the same x. So, let me take those red lines back off, and since that passed the vertical line test, yes, it is a function. The new term here on this one is one-to-one. A one-to-one function means that in addition to being a function and passing the vertical line test, there's also only one value for every x value, which means it passes the horizontal line test. If there's only one y value for every single x value, then it is one-to-one. If any of the y's repeat and does not pass the horizontal line test, then it's not one-to-one. So this one, yes, is one-to-one. There was only a vertical line and horizontal line will hit it once if it's one-to-one. And for the domain of this graph, we're going to look from left to right and look at the x's. Well, this graph goes left forever and right forever. So our domain would go from -infinity to +infinity. For range, we go lowest to highest, which is the y values, which goes from -infinity down to +infinity going up. Now, does this graph have a symmetry? Well, there's just a couple types of symmetry that we look at. One of them is y-axis symmetry, one of them is origin symmetry. There's also a term called x-axis symmetry, but if you talk about it, it's not a function, because when you have that symmetry, that is your line of reflection. So if you have y-axis symmetry, the y-axis creates a mirror image across it. X-axis symmetry would create a mirror across the x-axis, and then it's no longer a function. But sometimes you'll see that terminology discussed. Origin symmetry takes whatever is in one area, rotates at 180 degrees, and you see the exact same thing. So this function here, this linear function, has origin symmetry. And the very last term we want to talk about is this an even or odd function? Well, even functions have y-axis symmetry. So if it were reflected across the y-axis, it would be even. If it rotates 180 degrees and has origin symmetry, that is an odd function. And it could be neither, but in this case it was odd. So for the next function we're going to look at this quadratic function f of x equals x squared. So for every x value, we're going to square it, and that gives us the y value. So -2 squared is +4. -1 squared is +1. Almost put a negative sign. 0 squared is still 0. And 1 squared is 1, and 2 squared is 4. So if I plot 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, we can draw a parabola in. This is a quadratic function called a parabola. Is it a function? Yes, because none of those x values will ever repeat with different y values. You'll get a set y value each time. It doesn't change on that. So it does pass the vertical line test, is a much easier way to describe that. And so yes, it's a function. But this time, if we look horizontally, a horizontal line hits it more than once, which means there were more than one y value for every x. So no, it is not one-to-one. And so let me clear off my well, check off some of these marks that I made on here to try to make it less confusing or less busy looking. The domain for this parabola right here, it goes left forever and it goes right forever. So our domain is again all real numbers from negative infinity to infinity. Now remember, the common way to write that is in set notation would be with a capital R with the double lines, but for interval notation you do parentheses, negative infinity, comment infinity with a closed parentheses. The range is not all real numbers. This does have a low point. It never goes below 0. It equals 0 and then goes up. So the range is 0 with the bracket, because it's included, fit 0, all the way to infinity, and you can never include infinity. This graph, if you look at it, the y-axis is a perfect line of symmetry right down the middle of it. So this has y-axis symmetry. And if you have y-axis symmetry, you're an even function. Let's just keep moving along. The next function on the left is an absolute value function. Absolute value is distance from 0. So how far is negative 2 from 0? Positive 2. How far is negative 1 from 0? Positive 1. 0, 0, 1 is still 1 away from 0, and 2 is still 2 away from 0. So 0, 0, 1, 1, 2, 2 looks just like a line here. But we also have 0 or negative 1, positive 1, negative 2, positive 2. So we have a negative sloped line. Oops, I kind of got a little off there. So let me fix that real fast. I can undo that one. There, that's a little bit better. So that is an absolute value graph. It makes the V shape. If you look, a vertical line would only hit it once anywhere on there, so yes, it is a function. But a horizontal line hits it more than once, so no, it's not one-to-one. This graph does go left forever and right forever, so the domain is all real numbers, or negative infinity to infinity. The range is just like a parabola, 0 to infinity. It goes from 0 upward. And yes, there is a line of symmetry. I can see the y-axis splits this graph in half, so it has y-axis symmetry. And if a function has y-axis symmetry, it is odd. On the next one. For the next one, we have a square root function. And we don't want to look at the square roots of negative numbers because that's imaginary and we won't get to that until later. So this graph has to start, the first number we can take a square root of is 0, which is 0. The square root of 1 is 1. And I wanted to make nice whole numbers so you're not graphing decimals. So the square root of 4 is 2. Square root of 9 is 3. And square root of 16 is 4, but it doesn't fit on this graph. So 0, 0 is our endpoint. 1, 1, 4, 2. And then 7, 8, 9, somewhere out in here up at 3. This is what our square root graph looks like. It's half of a sideways parabola, if you notice. Is it a function? Yes, any vertical line only hits it once. So yes, it's a function. Is it one-to-one? Yes, a horizontal line would only hit it once. The domain is not all real numbers because 0 is the smallest it can go, so it is 0 to infinity. It goes right forever. The range, the lowest it goes is 0, and it goes up forever, so 0 to infinity also. And this one, whoops, that's a 0, by the way, my pen's off a little. There is no symmetry, there's no mirror image here, so symmetry, you can say none or NA or whatever you want to put for that. And is it an even or odd function? Well, if it has no symmetry, it has neither even nor odd function. Neither nor odd symmetry on that. On the next one, a cubic function. So we're going to cube every one of these x's. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. Negative 1 times negative 1 times negative 1 is negative 1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. These won't all fit, but we'll graph it as many as we can. 0, 0, 1, 1, negative 1, negative 1, and 2 8's probably somewhere up in here. Negative 2, negative 8 somewhere down in here. So just to show you what that graph looks like, it's this kind of skinny, stretched skinny graph there. Is it a function? Yes, every vertical line will hit it only once when you draw that on this one. Is it one-to-one? Yes, any horizontal line will only hit it once. And since as this is going downward and leftward forever, the domain, it goes from negative infinity, and as it goes right and upward forever, it's positive infinity for both the domain and the range. Now, if you look at the symmetry, this one, yes, has a symmetry to it. If you take that shape, it's not a y-axis symmetry, it's not mirrored over here, but if you rotate 180 degrees, you'll get the same shape upside down there. So yes, it has symmetry. It is origin symmetry. And a function that has origin symmetry is considered odd. Okay, moving on to the next one. There are different types of exponential functions, but we're going to look at 2 to the x. Later on, we'll probably talk about some 10 to the x and e to the x, but right now we're just looking at a 2 here. And if we raise 2 to a power, let's start with 2 to the power of 2 is 4. 2 to the first power is 2. And a number that's not 0 raised to the 0 power is always 1. And 2 to the negative 1 is 1/2. And 2 to the negative 2 is 1/4. So let's graph this. I'm going to start with 0, 1, 1, 2, and 2, 4. And then negative 1 is 1/2, and negative 2 is 1/4. This graph is called exponential growth here in this case. It's exponential, and it starts off really, really flat, and then takes off and gets steep. It's really, really close to the x-axis, but it never touches it. Is this graph a function, or is this a function? I'll give you a hint. If it have f of x, yes, it's probably a function. And in this case, yes, a vertical line would only hit it once. Is it 1 to 1? Yes. Even though it looks fairly flat in here, it is slightly increasing. A vertical line will only hit it once. Everywhere. A horizontal line, sorry. Horizontal line will only hit it once. The domain goes left forever and right forever, so it's all real numbers. The range, it goes up forever, so it is going to infinity, but the lowest it ever gets is 0, but it never touches 0, so it's a parentheses at 0. And there is no symmetry, so it is neither even nor odd. And we're zooming right along, we're down to the cube root function. Well, the cube root says what number times itself 3 times, some number times itself gives you -8, and if you look up, we saw -2 when you cubed it gave us 8, so the cube root of -8 is -2. The cube root of -1 is -1, cube root of 0 is 0, and then that one's 1 and that one's 2. You might notice some similarities between this graph above it, this table above it, and this table, so might be something to look at. To graph this one, 0, 0, 1, 1, -1, -1, -8, 7, 8, somewhere back over here is -2, and +8 is a +2, so it's similar to the shape above, but it's sideways version of it. Is this a function? Yes, any line that's going straight up and down will hit it only once. The x's never repeat. Is it 1 to 1? Yes, any horizontal line hits it only once. And the domain, because it's going left forever and right forever and everywhere in between, is -infinity to infinity. The range, because we're going down forever and up forever, even if it is kind of flat, it's still going downward and upward, is -infinity to infinity. So it's all real numbers again. And is there a symmetry? Yes, if you look this part right here, rotated 180 degrees, you end up with this part right here. So it has origin symmetry. And if you have origin symmetry, you are odd. And now for the last one. Let's talk about rational functions. We'll spend a whole unit on this, I think in the 5th, 6 weeks, maybe 6 weeks. But rational functions are anything that can be written as a fraction. So let's plug in some numbers here. 1 divided by -4 is -1/4. 1 divided by -2 is -1/2. 1 divided by -1 is -1. 1 divided by -1/2, when you divide by a fraction, you flip it and multiply, so that would be -2. 1 divided by 0, wait, we can't divide by 0, that's undefined. 1 divided by 1/2, you flip the half and that's 2. 1 divided by 1 is 1. 1 divided by 2 is 1/2, and 1 divided by 4 is 1/4. Now some of those are going to be hard to draw, but we'll try to sketch those in here. Well, if you have an undefined on a graph here, that's a vertical asymptote. So we're going to kind of just put a real light dotted line there. That's my imaginary line I'm never going to touch. So let's start with, let's do -1, -1. And then -2, -1/2. And -4, -1/4. And -1/2, -2. If you notice, this graph kind of does this. And then over here, if we do this one, 1/2, 2, 1, 1, 2, 1/2, and 4, 1/4. You can't touch that vertical asymptote, but you can get really close to it. And then we draw this, and it actually has a horizontal asymptote too that it never touches. So it hugs the x-axis and hugs the y-axis as it gets closer and closer and closer to it. And those are your horizontal and vertical asymptotes for that one. That's a rational function. Is it a function? Well, I just said rational function. Yes, any vertical line only hits one piece every single time. Oops, I'm drawing horizontal. Any vertical line only hits one piece every time. And since I was doing that, showing you, any horizontal line also only hits it once. So yes, it's 1-to-1. The domain for this one, it's coming along left forever, and it does go right forever, but it never touches 0. So the domain is everything except 0. If we were talking in inequality notation, you would probably just say x is not equal to 0. But for domain, you have to go from left to right. So we're going from -infinity until 0. -infinity until 0, but don't touch 0, so that's why it's parentheses. And then we union that, group that with from 0 to infinity. That means everything except 0. Everything before 0, everything after 0, but not equal to 0. Well, the range goes down forever, up forever, but it never touches 0. So the range is the exact same thing. -infinity to 0, unioned with 0 to infinity. Oops, that's a comma. And is there symmetry? Well, yes, there is. If you look at this shape right here and rotate it 180 degrees, you have the other shape there. So that has origin symmetry. And if you have origin symmetry, you're considered odd. And that is the traits for this. Next time, in the next video, you'll actually see some traits talking about when are these functions increasing, decreasing, and do they have any highest and lowest points, and what the intercepts are. Okay, thank you.